Okay, we're going to calculate some definite integrals here. Okay, so these are definite integrals. Remember that definite integrals, we're looking at the area under the curve. What I'm going to do with this particular question, this very first question, actually for all of these, I'm going to do a quick sketch to show you that the integral is the area under the curve. So what do I do here? Remember with that rule, don't we integrate this? Integrate it, go. What do you get? 2x squared over 2 plus x. Now you don't put a plus c with definite integrals. The reason is if you did put a plus c and we do the substitution of 4 and 3, we're going to substitute in the 4 minus substitute the 3. The c's would cancel, so you don't have to put the plus c in when you're doing a definite integral. 2's here would cancel, right? So we've got x squared plus x, then we have to substitute the values of 4 and 3. So we've got 4 squared plus 4, and I like to put it in brackets, minus 3 squared plus 3. Please show working out. You don't want to make errors here. So we've got, that's 20 minus what? 9 plus 12, which is 8. So therefore, it's telling me that the area under the curve between the values of 4 and 3 for this straight line is 8. That's if I do it as area or just integral, that's fine. Actually, we're just doing integral, so the integral is 8. Now, I want to show you how area under the curve is the integral. I'm going to draw the line y equals 2x plus 1. So I'm going to do the value of 4 and the value of 3. I know it would cut through there, but if I sketch y equals 2x plus 1, let's say I sketch it, when x is 3, what's y? Sorry girls, when x is 3, I get 2 times 3 is 6 plus 1 is 7. So actually I'm not going to worry about that bit. I've got 7. This is the point 3, 7. Because I'm just going to do a quick sketch of the line, right? And when x is 4, so when x is 3, I get y is 7. So I got 8 as my answer. I'm going to show you why we get 8 as the answer. Because it's the area under the curve between 4 and 3. It's the area underneath the line y equals 2x plus 1. Now you won't normally do this, but I'm showing you what integration is. So when you do a definite integral, you're getting the area under the curve. So this is telling me I want the area under the curve between the values of x is 4 and 3 for this straight line. Well, I've drawn the straight line. When x is 3, y is 7. Tell me, when x is 4, what's y? Come on, 9. So tell me what shape this is. It's a trapezium. Sorry, I shouldn't have that there. But area of a trapezium is h on 2, a plus b. I don't need that grid there. So tell me about the height of this trapezium. They're parallel, isn't it? What? What's the height? 1 on 2, 7 plus 9, a half of 16, which is 8. No, this is how you find the area under the curve, but I'm showing you that the area under the curve, because I chose a straight line function, we can just do the area under the curve with a trapezium. So I want the area under the curve y equals 2x plus 1. I can box it off. I can see that the shape is a trapezium. And if I just use normal area formula, I get that the area under the curve between the values of 3 and 4 is 8, which is the same as what I got for my integral. So what will happen sometimes is that you're not going to be able to integrate some functions. So you've got to resort to, wait, I can't integrate that, but I could use area formula instead. Now this one you can integrate. Now what happens in some questions, some people recognize it as, for example, a triangle or something like that. Let's say I looked at, I'll do another question in a minute with a triangle. I'll find the area under a triangle. I could either use integration or the area under a triangle to find it, all right? Do you see the link there? Now, I'll show you something like that in a minute again. Actually, we'll turn over. I'm just going to do another example. I'm just trying to show you the link between integration and area under the curve. So if I ask you to integrate 2x between the values of 2 and 0, let's say I ask you to do that using integration. What do? 2x squared on 2, and we substitute 2 and 0. So we're doing x squared, substituting 2 and 0. And what do we get? 4 minus 0, which is 4. Now, if I interpret that geometrically, I would draw the line y equals 2x, and I'm substituting, I'm basically finding the curve, the area under the curve y equals 2x between the values of 2 and 0. Couldn't I say that's a triangle? And it's what? The only thing is I need to know this value here. The base is 2. What's the height? When x is 2, what's y? So when x is 2, y is 4. So let's work out the area of this triangle. Half base height, which is, yes, no. So this is the line y equals 2x. If I'm asking for the integral between 2 and 0 of 2x, I can do it this way, which is how you will do it. But interpreting that as the area under the curve, it's the area under the straight line between 2 and 0. It's the area of a triangle. So what's the base? 2. And what's the height? 4. So half of 2 times 4 is 4. Do you see that? Now, the reason we need to know this is there are certain functions that you don't know how to integrate. Like, we don't know how to integrate semicircles, for example. We can't integrate the formula for a semicircle or a function that is a semicircle. Integrate 2x with respect to x. Okay, that's what the dx there is for. So we're just looking at the link here between integrating and area under the curve. This one, you don't know, we don't have a formula to integrate this. There's no formula. There would be if this was just an x, but not an x squared, all right? So we look at that and we say, well, we don't have an integration formula to do that, okay? So you look at y equals the square root of 4 minus x squared. Do you know what function that is? It's I'm going to square both sides. So if I ask you to do this, you cannot integrate it. This is where now our link between integration and area formula comes into play. I'm going to square both sides because, you know, when you square both sides, you're saying, where does this come from, sort of, when you've got these? X squared plus y squared is 4. Okay, what is that? If I square both sides, I get the whole shape, which is a circle. That is a, what's this? A semicircle. What are the, what's the center? What's the radius? So if I ask you to find the integral between 2 and 0 of the square root of 4 minus x squared, I'm asking for the area under the curve of a semicircle between the values of 2 and 0. Do you get that? It's the area. So that is y equals the square root of 4 minus x squared, that curve. But I'm asking you for the integral between 2 and 0 of this. You can't integrate this. You don't have the formula for it. So you have to resort to circles. Now, the only time that you'll use area formula are going to be for maybe trapezium, triangle like we just did, and circles. You won't use it for other things pretty much. So you tell me how to find that area. Isn't it a quarter of pi r squared? Yes or no? Which is, so I could say, well, the integral there I recognise as the area. So it's a quarter of pi r squared. What's the radius? So what's the answer? Pi units squared. What's if I asked you for the integral between 2 and negative 2 of this function? So it's asking for the area under the curve between the values of 2 and negative 2. How would I do that one? I'm going to do that one in red. So the integral between 2 and negative 2 is the area under the curve between 2 and negative 2. How much of a circle do I have? Bounded by the x-axis and the values 2 and negative 2. What have I got? It can't be integrated, so you've got to look for area formula. How much of a circle do I have? Half. Half a circle this time. Between the values x is 2 and negative 2. I've got a half of pi r squared, which is a half of pi times 2 squared, which is 2 pi units squared. Okay? Now, we're going to talk about negative integrals in a minute. These are all positive integrals. I'm going to sketch this. Tell me what this function is. You can't work out the area anyway using area formula for this one. But what is this? So let's just do the integral. Ready? Integrate, what do you get? 3x squared on 3 between the values of 5 and 0. Thank you. Very good. Which is x cubed, substitute between the values of 5 and 0. So notice I've got a positive value for my first question. The area is above the x-axis. I've got a positive answer for this second integral. The area bounded by, because the integral is the area bounded by the curve, the x-axis, and those values. And with this one, because my graph is concave down, when I look for the area bounded by the curve in the x-axis, it's below the x-axis. So that's why I get a negative answer here. So you need to listen very, very carefully. If I ask you for the integral, the answer's negative. But if I ask you the same question, if I say find the area bound by the curve, y equals negative 3x squared, the x-axis and the lines x equals 2 and x equals 0. Girls, do you ever get negative answers for area? You don't. The area bounded by the curve is 8 centimetres or 8 units squared. It's positive. But the integral is negative. So you've got to be careful. If they just ask you the integral, no context in the question, they're not talking about area, you write your answer as negative 8. Right? But if they ask for the area bound by that curve and the x-axis and the lines x equals 2 and x equals 0, the area, you do the integral, but then you make the conclusion. Therefore, the area bounded by the curve and the x-axis is positive 8 units squared, because there's no such thing as negative lengths and there's no such thing as negative areas. Okay? What is the integral? Area bounded by between the curve and the x-axis from 2 to negative 2 of the function x cubed dx. How do you do it? X to the power of 4 over 4 between the values of 2 and negative 2, which is 2 to the power of 4 over 4 minus, what's negative 2 to the power of 4? Over 4. What answer do I get? Now that's the area. That's not the area, that's the integral. Now I'm going to sketch it and we're going to see why this is happening. Anyone got any ideas? Because this is what it looks like. Sorry, I don't think I've drawn it the same. They cancel each other out. 2, 0, negative 2, 0. Those two areas are the same size. One's above and one's below. Actually, you can tell me here what the area is. One's if I asked you for, see now, if I ask you for the area bounded by that curve, you cannot give me 0. The area bounded by the curve is not 0. So, do you know what this area here would be between 2 and 0? You can see it here. It's more than likely going to be 4. Okay, so if I ask you a different question and I ask for so let's say I just do this. Notice that the integral between 2 and 0 of x cubed dx, let's just look from 2 to 0. you get x to the power of 4 on 4 between 2 and 0, which is 16 on 4 minus 0, which is 4. So, therefore, I could say that this area is 4 units squared. Are you okay with that? And this area is also 4 units squared. So, therefore, the area bound by the curve y equals x cubed, comma, the x-axis, and the lines x equals 2 and x equals negative 2 whoops, everything's a bit crooked. Trying to get straight here. What's the area? No, not the area. The area is 4 plus 4, it's 8 units squared, but the integral between 2 and negative 2 of x cubed dx, sorry, yeah, each one's 4. Oh, I could do the other one. How do we know it's 4? So yes, we know if I actually did 2, 0 there and I got 4, if I do the integral between 0 and negative 2, actually I'll do that again over there in a minute, but I know that this area is 4 and this area is 4 because it's symmetrical. Like it's got point symmetry. It's an odd function. It's got point symmetry. So the area bounded by the curve y equals x cubed, the x-axis, the lines x is 2 and x is negative 2 is 4 plus 4, which is 8. But if I asked you with not area, what is the integral between 2 and negative 2 of x cubed dx, I would get what I got up here, 0. Why? Because the top area and the bottom area cancel each other. The reason is when you do the integral between 2 and 0, you get positive 4, but when you do the integral between 0 and negative 2, what do you think you'll get if I just did the integral between 0 and negative 2? Negative 4, because it's below. I'm going to do it over here. So, watching. One sec, I'll just make this wider. So, notice that if I do the integral between 2 and 0, I get positive 4. But if I do, now, why do I write not, you don't write negative 2, 0. You always go higher x value and lower x value. So the integral between 0 and negative 2 of x cubed dx, just watching. So if I was asking you for the integral between 0 and negative 2 of x cubed dx, it's going to be this red area, right? This is the red area. So let's do that. What do you get? x4 on 4, substitute 0 and negative 2. See, the order of substitution is really important. And what do you get? Isn't it 0? You substitute the 0 first, minus negative 2 to the power of 4 is 16 on 4, which is 0 minus 4, which is negative 4. But the area will be the absolute value of that, okay? So if we're doing something and you notice that a portion is below the x-axis, the area will be the absolute value for this section. Do you get what I've done? Because I know that this bit is below the x-axis, the integral will be negative 4, but the area is the absolute value of that, which is positive 4. Sorry. You okay with that? Absolute value of negative 4, which will be positive 4. Now we're going to do some questions like that where we know that the curve's going below the x-axis and stuff like that. Actually, I think we do those later. More now. Integrate root x between the values of 3 and 1 dx. What do you do? That's the same as integrating between the values of 3 and 1, x to the power of a half dx, which is, what do we get? X to the 3 on 2 over 3 on 2, which is 2/3 x to the 3 on 2. Because it's x to the 3 on 2 divided by 3 on 2, which is, instead of dividing by 3 on 2, you times by 2/3, just substituting the values of 3 and 1. Now, obviously, I'm not going to be able to work this one out. So I've got 2/3 times 3 to the 3 on 2 minus 2/3 times 1 to the power of 3 on 2. If I had some different values here, I'd be able to evaluate that. If it was between 9 and 1, or, oh, no. Yeah, no, if it was a different value, I'd be able to, but I can't. So what do I get? It's just 2/3. Well, how would you write this? Root 3. Oh, you can evaluate it to a decimal place or something. Root 3 cubed. Yeah. Oh, actually, we can rewrite that. Let's do it as an exact. Minus 2/3. Keep going. How can I write that as an exact value? Are we okay with this? 2/3 root 3 cubed. What's root 3 cubed? Root 3 times root 3 times root 3, which is, this is 2/3 times 3 root 3 minus 2/3. Just trying to do an exact. Let's find the exact. What cancels? The 3's, and you get 2 root 3 minus 2/3. So you can and often will be asked to work it out as an exact value. And that's as an exact value. We all know that you could throw it into your calculator. All right? Can we see that? All right, next one. The reason I put this one is it doesn't always have to be x. This is asking you to integrate with respect to y. So it's just the same. That's all. And what do you get? y4 to the power of 4 on 4 plus y squared on 2, just substituting in your values of 2 and negative 2. Please do the whole substitution for 2 first, minus the substitution for negative 2. Now, your powers are all even, so it's not going to matter. Which means, what are you going to get? You should get 0. So, in other words, actually, just look at the original curve. They're all odd powers. This is an odd function. This is an odd function. And if I go into Desmos and graph that, it's probably going to look like this. And it's got point symmetry. And this is why you're getting 0. So I've got 2 to the power of 4. What's that? 16 on 4 plus 4 on 2 minus negative 2 to the power of 4. Again, same values. But please put them in brackets. Work out each bracket first. What's that? 4 plus 2. 6 minus 6 is 0. The reason this is happening is because we're going on either side to negative 2, but it's got point symmetry. It's obviously passing through the origin. And it's an odd function, and that's why you're getting 0. That would only happen if you're doing 2 and negative 2. If I was doing 2 and negative 1, I'd probably get a positive value. And if I'm doing 1 and negative 2, most of the curve will be below. I'll probably get a negative value, depending on, all right? And what do you think you're going to do with this next one? We were doing stuff like this yesterday. There's no quotient rule for integration. So what should I do with this? Divide each one by x individually. Yeah, but not just one of them. You've got to divide each one by x. And what do you get? X cubed minus 3. This is a common denominator, meaning that each term is on x. So you write it separately. You don't make a mistake, right? Yes, you could factorize the numerator, cancel some x's. So that, if you see anything like this, that's all you've got to do. All right, so what do we do here? All good? So what do you get now? X to the power of 4 on 4 minus 3x, substituting in the values of 1 and negative 2, a quarter minus 3 minus 4 plus 2, sorry, 4 plus 6, so this is 10 minus Oh, sorry, negative 10. What's this? Anyway, go. It's negative 2 3/4, isn't it? Minus 10. Oh, it's negative 12 3/4. Is that right? Which is, and if you want to write it as an improper fraction, you can. Yeah. All right, and the last one, again, you would just make sure you're dividing each term by 3x to the power of 5. All right. How would you write this one? A third. Do you want to write it as x on the numerator because you're not going to be able to integrate it otherwise? X to the negative 3 plus. Oh, actually, we're going to do something with this in a minute, and I should have done it before. You're going to notice something, and we'll do it in a minute. What have we got? X to the what? Anyone know what I'm doing? What should I write? What do you want me to write? No, x's cancel. Negative 4 plus. All right. I could have either taken the third out, which probably wouldn't have been a bad idea. So can you see how this has the 3 here? I really should have put the 1/3 out the front. But you might say, but don't do that because these two are going to cancel. Do you know what I mean? So if you'd, but I probably still would pull it out the front. You know why? You're going to be dealing with thirds all the way through. So what I'm going to do, I am going to pull it out the front. So I'm just going to keep this as 3 over 3 x to the negative 5. Now what I want to do, I want to pull out the third because I'm telling you, it'll be easier for you when you start substituting. That's why I've just left that at the moment because I've realized I should have pulled out a third. Watch. A third times the integral x to the negative 3 plus x to the negative 4 plus, what do I write here? I took the 3 from 3x to the negative 5. Now, I'm telling you that is going to be much easier to substitute with no thirds in the substitution. This just shows what we should, if we see the 3 there, I would have should have really from the beginning just written it as this. And then, do you know what I mean? And then I could have divided each one by x to the power of 5. So that would give me x to the negative 3 plus x to the negative 4 plus 3x to the negative 5 dx. So that's where we are there. Do you see? Now, let's do the integration. What do you get? Remember you're adding 1. Please be careful. What do you get? Negative 3 plus 1 is? What is it? Negative 2 over negative 2 plus negative 4 plus 1 is negative 3 plus, actually it probably wouldn't have been so bad because we got these 2's and 3's. We could have left the third in, doesn't matter. Negative 4 over negative 4. Substitute 4 and 3. So much for my pulling the third out. It doesn't matter. You've got fractions everywhere anyway. A third. I would rewrite this as, come on, negative, what am I going to write here? X squared. Please put it back as a positive power of x minus a third x cubed. Actually, the 3 on the bottom wouldn't have been so bad after all. Minus 3/4, and the x to the 4 is on the denominator. But look, it doesn't matter because when you're finished, you multiply everything by a third. Okay? A third. Have fun. This is where you don't pull your calculator out straight away. Can you see what I've done? I don't want to be substituting with x to the negative 2, x to the negative 3. You bring it down to normal powers. Substitute in 4. Negative 1 over 2. Actually, isn't that going to be 16? 32 minus 4 cubed is 64 times 3. Pull it out. 192 minus, well, this is 4 to the power of 4 times 4, so it's 4 to the power of 5. minus 3 over whatever 4 to the power of 5 is how much? 1024. Close bracket. I need a big square bracket too because it's a third times the answer to all of this, minus, right? Fun. So notice my third's got to be multiplied by the whole answer. So now I put my 3 in. It's negative 1 over 2 times 9 is 18. Minus 1 over, this is 3 cubed times 3. 3 to the 4, it's 81. Minus 1 over 81, no, 3 over, actually, 3 over one of these 3's cancels. So it's 27 times 4. 5,408. Like that. What's 3 over 4 times 3 to the power of 4? 3 to the power of 4, and one of these 3's cancel. So it's 3 to the power of 3, which is 27 times 4, is 54, double it, 108. So it's that. Now, do you really want to be working with, look at all these negatives. You've got 2 options. You can do a third. You can just work this out on your calculator, write an answer. If you want negative, 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 it'll just be plus the addition of these. Do you see? I wouldn't be doing all the negatives. You're going to have minus, 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 minus. I would just add those 3 together. So this is going to be a negative 1 plus this answer will be positive. How are you going?
First bracket is minus 121 over 3072.
And the second bracket, you just add those 3 together. Can you see you're going to be all plus, plus, plus? Because it's minus, 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 minus. Just add the 3. They're all 8s, a lot of 8s. So 1/18 plus 1 over 81 plus 1 over 108. All plus. So now it's 25 on 324 minus 121 over 3072 equals times a third or divide by 3. Or you take, yeah. So girls, you've got to do that minus this. Get an answer. Please get an answer. Because otherwise it'll just times this one by a third. What did you get? You must do that minus this. Because it's negative that plus that. Get an answer and then times it by a third or divide it by 3. What do you get?
0.012.
Doesn't give you a fraction? 0.0, etc. Whatever. Just 3 examples. Exercise 3.4. Indefinite integrals. We've done primitive. This is the same thing as just writing it a different way. Notice there's no numbers. So this is indefinite integral. You've got to put plus c. What we were doing yesterday. So exercise 3.4 is what we were doing yesterday. The only difference is instead of them saying find the primitive function of, we just put the integral symbol. Okay, so what do I do? Can I do this?
Yeah. No, change it.
X squared times x to the half dx, which is x to the power of what? What do I do with the 2 and the half? Add them. 2 and a half is 5 on 2 dx. So notice I keep my integral symbol while I'm still manipulating how it looks. And now I do the integration. I add, that's 2 and a half. 2 and a half plus 1 is 3 and a half, which is 7 on 2 over 7 on 2 plus c. But then we change the way it looks. And what do I write? 2/7 x to the... Now let's write it the way the question was written. I can either go square root of x to the power of 7. Are we okay with that? You're not because you can't see it. Plus c. We did these yesterday. Okay? Just practicing the notation here. 2/7 square root of x to the power of 7 plus c. Ladies? Yeah, okay, just make sure that looks like a proper 2/7, not a 7th root or anything. How would I do the next one? Is there a product rule for integration? No. So what would you do? Expand. 3x squared No, it's not. X cubed plus 3x squared minus 4x minus 12 dx, and off you go. So please, there's no product rule for integration. Expand until we learn there is a new rule coming up.
Is it?
It's not long.
Next video, we'll learn how to do it.
Actually, we'll do it in a minute.
No.
Hopefully I haven't made a mistake there. I knew I made a mistake. 3x cubed. Yeah. And the last one. So what's the last one? How do I write this? 1/3. What do I do with the x to the 4?
X to the negative 4.
Are you okay with that? All right, let's go. 1/3 times, because the third's a constant, x to the negative 3 over negative 3 plus c. Be careful. Negative 1/9. X cubed on the bottom plus c. Be careful.